Welcome back to Mr. Page's classroom. This lesson is for my Algebra 1 class. It is 4.5 Compound Inequalities. The objective is to solve and graph compound inequalities. We have some vocabulary terms. A compound inequality is two inequalities that are joined by the word and or the word or. There's a process that we'll use if it's the word and. There's a different process we'll use if it's the word or. Okay? Example 1. Writing a compound inequality. Write two compound inequalities that represent each situation, and then graph the solutions. So it says all real numbers that are at least -1. If it says at least, that means we're going to use greater than or equal to. So that one's already been written for us. Okay? If it then says at most 3, that's when I'll use less than or equal to. We've talked about that in the past. So I'm going to put 3 in the blank. Now I want to go ahead and look at these signs. See where my n value is. I need to put one of the numbers in this blank and one of the numbers in that blank. Okay? The easiest one is to look at this second inequality back here. It says n is less than or equal to 3. So there's my less than or equal to sign, so 3 would in fact still go there. If I take this inequality, it says n is greater than or equal to -1. Well, there's n, there's the greater than sign still pointed at n, so -1 will go there. Alright? Hopefully that's not very confusing for you. Okay? So now what I need to do is go ahead and graph this. So the first thing I'm going to graph is -1 is less than or equal to n. So I'm going to go ahead and go to -1. It says that it is less than or n is greater than or equal to that, right? So I'm looking at this is how I want to think about it. So my arrow is pointing to the right. But before I go ahead and graph that, I need to also graph n is less than or equal to 3. So I'm going to also go ahead and put a point at +3. Now, this is saying that I'm going to go this way from that dot and this way from this dot. So it's everything that is in between these two. Alright? They actually are, it's going to be the area in between our two numbers when it is an and problem. Okay? So let's go ahead and look at our example 2. It says solve 5 is greater than 5 minus f, which is greater than 2. Then solve the solutions. How I'm going to do this is I'm going to take 5, which is greater than 5 minus f, and make that one inequality. Then I'm going to take 5 minus f is greater than 2 and make it a second inequality. I'm going to solve each inequality individually. So 5 minus 5 is 0, which is greater than -f. You divide by -1, divide by -1. So 0 would be less than f. Okay? Here, I subtract 5, -f is greater than -3, divide by -1, f is less than +3. So this is an and problem. Anytime it is written like this, we can automatically assume that it is an and problem. Alright? So now what I'm going to do is I want to rewrite these answers with the and in between the way I did up here. Okay? So I have f is greater than. So here it says n is greater than. So f goes in the center. It is greater than 0, so I write it that way. It is less than 3, so I want to put the f in between where I'm going to put my points. Well, the f is everything between 0 and 3. So if I make a graph, okay, I'm going to put an open circle at 0, an open circle at 3, and I'm going to shade everything in between because my answer, f, is in between 0 and 3. Alright? Down to part B, I'm going to go ahead and separate these again. So -1 is less than 4m plus 7, and 4m plus 7 is less than or equal to 11. Notice when I was saying that, I said the word and in between, right? Okay? So I'm going to go ahead and subtract 7 from both sides. That would get me -8 is less than 4m. Divide by 4. That would get me -2 is less than m. And over here, I need to subtract 7. So 4m is less than or equal to, that would be 4, I'm sorry. 11 minus 7 would be 4. Divide by 4, divide by 4. M is less than or equal to 1. This is an AND problem. So remember, I have to write my M in between. So again, I just write negative 2 is less than M. M is less than or equal to 1. So now I need to make my graph. It's going to be an open circle. I'm sorry, I shouldn't have written it like that. This sign is just less than, so it'll be an open circle at negative 2. This sign is less than or equal to, so it'll be a closed circle at 1. And my answer is everything in between. Okay? So that's how we work through our problems if they are AND problems. If they are OR problems, I need to write two inequalities that represent each situation and graph the solutions. So it says all real numbers that are less than 0. So here it says n is less than, I'm going to put 0. Or are greater than 3, so n would be greater than 3. I don't have any more work I need to do at this point with this problem, so I'd have negative 1, 0, 1, 2, 3, and 4. I need to graph this first one first. So n is less than 0. It's not less than or equal, so it's going to be an open circle at 0. And it'd be everything less than 0. And it would be n is greater than 3, so it'll be everything greater than 3. All right. Let's keep going. So here I need to solve a compound inequality containing OR. I have solved 3x plus 2 is less than 7. Notice that's already here. I have negative 4x plus 5 is less than 1. That's already here. And the word OR is in between. Okay? That will come into play here in 1 second. That will come into play here in 1 second. I'm going to go ahead and subtract 2. Subtract 2. 3x would be less than 5. Divide by 3. Divide by 3. So x is less than 5 over 3. If I put that into a decimal, I don't like putting it in a decimal, but it just helps us think about the graph a little bit. That'd be 1.66 repeating. Just so you have a thought about how that would work. Okay? Do not change that to a decimal, though. I want that as 5 over 3. Subtract 5, subtract 5. Negative 4x would be less than negative 4. If I divide by negative 4 on both sides, x would, because I divided by a negative, I need to switch my sign, x would be greater than 1. So x is less than 5 over 3, or x is greater than 1. Well, I can go over here and make my graph. Why did I leave that mark in between 1 and 2 blank? Because that is my 5 over 3 location. Okay? So what I'm going to do here is it says that x is less than 5 over 3. So I have an open circle at 5 over 3, and I'm going to shade to the left because it's everything less than 5 over 3. These OR problems really don't have a lot to do with each other until you'll see on the next one when they would a little bit. Then I would have an open circle at 1 and shade everything this direction. Notice that the entire line is shaded all the way through, so this would be all real solutions. In my x is less than 5 over 3, 5 over 3 is a whole. In my x is greater than 1, 1 is a whole. But my shading from my 5 over 3 problem goes through 1, so that makes it a viable answer. And my shading for x is greater than 1 goes through 5 over 3, so that also makes that a viable answer. So it is all real solutions because my solution just has to be in one inequality or in the other inequality. Okay? That's why that works that way. On to B, I can go ahead and subtract 5. Subtract 5. 2d is less than or equal to negative 6. Divide by 2. Divide by 2. d is less than or equal to negative 3. Or subtract 5. Subtract 5. Be negative 2d is less than or equal to 0. Divide by negative 2. Divide by negative 2. Because I divided by negative 2, I need to flip my sign. So d is either less than or equal to negative 3, or it is greater than 0. So I need to go ahead and make my graph here. Okay. d is less than or equal to negative 3. Close circle at negative 3 because it's equal to. d is greater than or equal to 0. Close circle at 0 because it's less or greater than or equal to. And I am done. Okay. Solve and graph the compound inequality. It's an OR problem, so I'm going to treat them pretty much like they have nothing to do with each other. If they end up crossing over, then I can say all real numbers, right? But let's see what happens. So add 8, 3x is less than 15, divide by 3, x would be less than 5. Or add 9, 2x is greater than, this would be 10, divide by 2, x would be greater than 5. Okay? So now, both of my inequalities work at the spot 5, correct? They both have open circles at 5. I have one that is less than 5. I have one that's greater than 5. So what does this really tell me? It tells me that it is all real solutions except 5. Because both of those inequalities say that neither one are equal to 5, then there can be a hole here at 5. Everything that's smaller than 5 would work as a solution for this inequality. Everything that's greater than 5 will work as a solution for this inequality. So it's all real solutions except 5. Now we need to discuss what happens in our solutions. So if I have an AND problem, it's only the solutions that overlap. So it's the overlap. Oh, I'm sorry. It is the overlap only are my solutions. If it is an OR problem, I can have, it'll be two distinct regions. Okay? I can have all real solutions, or I can have all real solutions except a certain number. All right. Well, that is the end of our lesson. The most important things here are to go back, make sure you understand that if it's an AND problem, that my answers will be where they overlap. If it's an OR problem, they will have two distinct regions, and I could have all real solutions, or I could have all real solutions except a certain number. Make sure that if you have any questions, you go ahead and bring them to me tomorrow. Thank you very much for watching the video, and have a